Now on to the second example, where we'll learn something different from what we just learned, because this one does involve a series that has negative terms in it. So this is in fact an alternating series. So we see here that the ratio test also works for alternating series. Okay, so let's do our basic check again. If I look at this, now this entire thing is my a sub n, are any of the terms ever zero? The answer is no. I have exponential growth and I have something squared, so never zero. They alternate, plus minus, stuff like that, but they're not ever zero. So check for this first one. And then here, I do need the absolute values. I'm going to put them in here, but I'm just going to show you. So n plus 1, everywhere I see an n, put a n plus 1 squared, and then divided by an, which is the original terms in the series. I'm going to show you why. Basically, when you have an alternating series, you don't have to keep track of things so much with the negative ones, because here, right, this negative 1 to the n plus 1 is inside the absolute value. So when I take this absolute value, it gives me 1. Oops, I missed a negative 1 to the n here. This negative 1 to the n is also inside the absolute value. So when I take its absolute value, I also get 1. And then everything that's left over, this and this, they're already positive. These things are never negative. So I don't have to worry about those negative 1 to the n plus 1s or that negative 1 to the n. Because of the absolute value, they turn into 1. Okay, so I'm over here. And what's happening is kind of now what happened before, except the algebra looks a little more difficult, but it won't end up being that much more difficult. Division is multiplication by the reciprocal. There we go. And then I'm going to group together everything that is not an exponential function, and then everything that is, so times 3 to the n plus 1 over 3 to the n. For similar reasons, right? Here, this is 3 to the n times 3 to the first. These 3 to the n's are going to go away. I'm going to be left with 3. And then over here, I can put everything into one fraction and then square it. So that's another one of my rules of exponents. And I'm taking the limit as n goes to infinity of this thing. And so now I get to say a few things. First of all, the 3 goes out front, right? So that's one of our limit properties. And then also the limit can go inside. That's another limit property because I'm looking at a continuous function, something squared. So now I'm taking this limit and same deal. L'Hopital's rule, factoid about the rational functions or growth argument. In this case, that last one says, hey, plus 1, I can ignore that because I'm going to infinity. This limit is tending toward 1. So I'm getting 3 times 1 squared. I'm getting 3. And I go off and say, okay, that is definitely bigger than 1, right? Always comparing to 1 for the ratio test. Bigger than 1, I'm here in this case. So the series diverges, right? So that's our conclusion for part B. Series diverges.